Hello everyone, welcome back to our lecture series today. Today we'll be talking about the nomenclature of alkanes. Remember, in the last chapter we introduced alkanes, and today we're going to be looking at the nomenclature of alkanes. And the importance of this is that the nomenclature of alkanes will be the foundations for us to name every other class of organic compounds. So this lecture is very, very important and foundational to your proper understanding of all the concepts you're going to be considering in organic chemistry. All right, so let's move on from the I have something for you. It says, life begins at the end of your comfort zone. This quote is from Neil Donald Walsh. I'm not going to say anything about it. It's a food for thought. Let us move on with our lectures immediately. So at the end of this class, what are the learning objectives or the learning goal we intend to achieve? Number one, we're going to learn to use IUPAC. IUPAC means International Union of Pure and Applied Chemists. It's a union of chemists that come together to decide on a general rule of nomenclature in chemistry. So everybody has to follow this rule. So we understand how to use IUPAC to name alkanes and their derivative, given a structural formula. If you are given a structural formula, you can now name the compound. We can also know how to draw the structural formula of an alkane and the derivatives given the IUPAC name. So if you are given an IUPAC name, you can easily draw the structure of. So if you are given just the name, the IUPAC name or the IUPAC nomenclature, you can easily draw the structural formula. So these are the two things we'll tend to achieve at the end of this class. Let's take it off immediately. IUPAC naming system, the IUPAC nomenclature. Like I said, the IUPAC simply means International Union of Pure and Applied Chemists. That's exactly what it means. It's the highest decision-making body when it comes to nomenclature of compounds, both organic or inorganic. So now the IUPAC nomenclature is different from the old nomenclature. The old nomenclature, or what we call the common nomenclature, is the trivial system, common nomenclature. And in fact, over the years, nomenclature has actually changed. And like what we're currently using, what I'm going to teach you now is still not like the current IUPAC nomenclature system. But that at the point, that is what is being used in this part of the world. Let's take it off from there. Now, the IUPAC nomenclature has three branches, has three areas. Now the name is divided into three areas, into three categories: the prefix, the root, and the ending. Now the prefix tells us the number and identity of the attachment. An attachment is something that is attached to the long carbon chain. Now the root tells us the longest carbon chain. What is the longest carbon chain? Remember, we said organic chemistry is the study of carbon compounds. So one thing is that is common in organic compound is that they always have carbon on their chain. So there's too many carbon you're going to see all around. So in any IUPAC nomenclature, the first thing you want to do is to identify the longest carbon chain. And then finally, the ending tells us the functional group class. That class, is it an alkane? It's going to end in A-N-E. Is it an alkene to end in E-N-E? Is it an alkyne? It can end in Y-N-E. That is exactly what I said. So for alkanes today, we're going to see it end in A-N-E because that is the functional class. That's what we're considering today. For the alkanes, it's going to be ending in A-N-E. So the root here is going to be this A-N-E for us. That's exactly what we'll be talking about today. The root is going to be this, and the ending rather will be this A-N-E. That's what we'll be talking about. Okay, let's see what happens. So to demonstrate this example, I came up with something. So we're going to use these two. These are two the same thing. If I count this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is, I just want to make sure that I didn't make mistake. So this is the same molecule. So I'm going to use it to demonstrate the IUPAC system of nomenclature. What am I going to do? Now, this is the name of this compound. Look at how I did it. Now, the green side is the whole of this, like 2-methyl is the prefix. So I use this green color. Now the purple color here, if I'm not mistaken, I'm bad in colors. Pent is the root name. Pent is telling us the longest carbon chain, and pent means 5. And then the functional class, the A-N-E, tells us that it's an alkane. Let's see how we arrive at this point. So the three of these is what make up the components of the IUPAC nomenclature. Like I told you, it has 3 components. Now let's see, or 3 categories, or you say 3 parts. It doesn't matter. Whatever you want, whichever word you want to use. Now, let's see what happens here. The first thing we're going to do in IUPAC nomenclature, we're going to see the steps much later from this, after I explain this. is to count the longest carbon chain. So I want to count the longest carbon chain. The longest carbon chain can be this. Okay, let me start from this one because I showed the carbon here. This is the shortcut. Now, if you count this 1, 2, 3, 4, 5, that's the longest carbon chain. 1, 2, 3, 4, 5. So I'm going to count from here. 1, 2, 3, 4, 5. I can also count from the other. So let me count from the other way. I'll tell you why. If you count from here, 1, 2, 3, 4, 5. The longest chain is 5. So we've counted that. So what it means is that we've known that this is pentane. So we've counted this. So we know the longest chain is 5, pent. Is there any attachment? Yes, there's an attachment. Let's see. What is the attachment? There's an attachment at this point. Remember, the attachment is what? The prefix. So we have to say the number where it is attached and the identity. So the identity of this attachment, this is a metal. Remember, this attachment is metal. So that's what we have here as the prefix. It is metal. Where is it attached? Now, let's decide. How do we decide where this is attached? I tell my students, this is another place you need to do some thinking. Now see what is going on here. The rule is that you have to give the attachment the lowest numbering. If you count from, look at my green counting, 1, 2, 3, it gives the attachment number 4. When I count from my left side, no, from my right side. If I count from my left side with the red, it gives it number 2. So the best number that will be reasonable is the one that gives the what? The attachment or the substituent the lowest number. So what that simply means is that I'm going to take away this, I'm going to take away this. This is a wrong numbering. So the numbering system that will suffice will be this particular one. Will be, remember, so will be this one. So what it means is that the methyl group is attached in carbon number 2. That's why I have 2-methyl as the prefix. The longest carbon chain is 5. Pent means 5. Pent is 5. The Greek prefix means 5. And then it is, see this, the carbon to carbon single bond. That's how we know alkane. The ending is ANE. That's what we call it alkane. So this is exactly how we name using the IUPAC nomenclature. So these are the components of the IUPAC nomenclature. And this is exactly what we're going to be doing throughout this place. So if I want to name this now, it's going to be 1, 2, 3, 4, 5. It's the same thing. Remember, this is a shortcut for methyl group. So this is metal. This again, 2-methyl pentane. This and this is the same thing. I just decided to draw 2 of them. So just to see you, since we're going to be entering into this nomenclature with different forms, either shortcut or full. All right, let's now see. So now, the IUPAC nomenclature for alkanes that are unbranched, for the unbranched, or if you don't want to call them unbranched, you can say normal. Remember, I used this word already. For the normal alkane, because they don't have any branching, they don't have any attachment to the longest carbon chain. Now look at what happens. Let me go to the previous page. We don't need this, so you remove this. When you remove this, you only have the root and the ending. Look at it. We only have the root and the ending. So the root tells us the longest carbon chain. Of course, as usual. The root shows you the number of carbon in the chain, the longest carbon chain. Whereas the ending ANE tells you that this is what a saturated carbon. So this is just the 2 parts. There's no attachment. We don't need to put the sulfur. So now, what is now your responsibility? It is your responsibility to memorize what? To memorize all these Greek prefixes that represent the carbon chain. Met means 1. Number of carbon chain is 1. Et 2. Prop 3. But 4. Pent 5, like we used in the previous slide. Hex is 6. Hept is 7. Oct is 8. Non is 9. Dec is 10. So you need to memorize this. This is going to help you in all the nomenclature of all classes of organic compounds. So if you want to write methane, methane has only 1 carbon. What do? You say met, which we have here, plus ANE. Remember, it is always ANE for methane. If you put ANE here, it's going to be methane. That is it. We've just named with 1 carbon that has no branch. If you want to do, let's say, propane, it's going to be prop plus ANE. What are you going to have? You have propane. Means 3 carbon. If you have hept plus ANE, what are you going to have? You're going to just have heptane. Longest chain with 7. That's exactly how you name. So naming unbranched alkane is very easy and trivial. But however, that is not the job. This is only the foundation on how to name more complex ones. So the names of the unbranched or normal alkane are given below: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane. Just like I told you, they're easy to name. Now, this is going to build a foundation. And another thing you need to do, you need to know how to draw their structural formula. So assuming I want to draw the structural formulas of this guy, how do I do that? We can easily draw their structural formulas. Remember, how do we draw the structural formulas of this guy? That is very much easy. The structural formula is going to be, methane means only one carbon. So it's just this one. Only one carbon in the chain. Remember, they are completely saturated with hydrogen and they do not have attachment. So ethane is going to be 2. So it's going to be 2. I'm going to make it a shortcut. The shortcut of ethane, this will be methane. Ethane is going to be just 1. This is 1, 2 carbon. This is what it is. So this is ethane. So propane is going to be 1. This is 1, 2, 3. This is propane. So assuming I want to draw, let's say, hexane is going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Remember again, you can always number. This will be 1, 2, 3, 4, 5, 6. This is what? Hexane. If I number this 1, 2, 3, it's 1, 2. So this is using the skeletal structure. These are the skeletal structure or line angle structure. Let's take it off immediately from there. Now let's talk about the alkyl groups. Let's talk about those so-called attachments actually. What importance do they have? So alkyl groups are substituent to attachments that are derived from the alkane. They actually derive from alkane by removing hydrogen atom. They almost go with the same formula. Look at what I'm going to, let's see what happens here. Now, remember methane, this is methane, right? If you remove one hydrogen from this, it becomes CH3. This CH3 becomes an attachment. How do we name it? What do you need to do? You just put YLE. So you're going to remove ANE and put MET, which is 1 carbon, YL becomes methyl. So that is how you derive this guy. So they are named by dropping, like I said, the ANE from the name of the parent alkane and adding YL. So if it is ethane, it's going to be ethyl for 2. 3 will be propyl and all the rest of them. Now, I've given the shortcut in this image, but before we do that, I'm going to take you to the next page to look at the full structure before we come back to the shortcut. Methyl group, like I told you, only has 1 carbon. That means it has only 1 carbon. And remember, if methane is CH4, methyl will be CH3. Remember, and what will be the formula? The formula is given to you there. All right. So the same thing here. These are all the structural formula of this one. So ethyl is 2 carbon. So here, if you want to just write the formula here now, the shortcut formula or the condensed will be C2. Let me use my red. Will be C2H5 because this 3 plus 2 will be 5. This ethyl, propyl is 3. Propyl will give you, propyl have 2 types. Propyl will be C3 because propane is C3H8. So if you remove 1 from there, it's going to be C3H7. And when you count it, 1, 2, 3, and 2, 4 plus 3 is 7 hydrogen. Now, propyl have 2 types. Propyl have a propyl and isopropyl. Isopropyl shows you, look at isopropyl here. Isopropyl means we now take out one of these and use it as a branch point at this point to give you this. This is propyl. I'm going to show you the shortcut in the page I looked at before this. So we're going to get to that place. In the preceding page, I have the shortcuts there. So this is propyl. In fact, if you want to draw propyl, propyl looks this way. You're going to attach it to something and just put it this way. This is propyl. So assuming you attach it from a long chain, we don't know anything there. So this is 1, 2, 3. This is propyl here. And then this is butyl. Butyl is 4. Again, propyl will always have the same formula here. Butyl, this is 1, 2, 3, 4. 4 carbons. Here, the longest, this is unbranched one, is butyl. So the formula will be C4H. If you count the number of hydrogens, let's count and see what it gives you. It's going to be 9. But if you count 2, 4, 6, 6 plus 3 is 9. Now, butyl have 3 types. These are the common ones. Remember, these are just the common alkyl groups we'll be using. There are so many of them. There could be pentyl, hexyl, and all the rest of them. Now, to form the isobutyl, what do? You break out this point and attach it at the second carbon. It becomes this. It becomes isobutyl. All of them have the same formula. Remember, it's still C4H9, C4H9. All of them. C4H9 for all of them. Now see, isobutyl means breaking one of these and attaching it at this point gives you this. And if you count again, 1, 2, 3, 4 is 4 carbon. Now what about sec-butyl? Sec-butyl means breaking one off and putting it in the first one here, in the first carbon here of it. That gives us sec-butyl. Whereas tet-butyl means breaking one off here, breaking one and putting here, and breaking another one and putting here to look like this. So I usually tell my students this looks like a cross. Or you can say Christmas light. So whichever one you want to call it here, looks like a cross. So when you see it drawn, usually we draw it like this. If this is the long chain, maybe attached to something, this is butyl because this is 1, 2, 3, 4. This is usually all this. So let's go back to this and see their shortcut. Look at the shortcut. So I take this to be the long carbon chain attached to something. So remember, all of these guys are attachments, and we need to know and understand that. So let's see the attachment. So this is the shortcut for metal. This is just 1. So this is metal. Remember that? When it is 1, 2 carbons from attach, you cannot count it from here. It must be counted from here. This is 1 and 2. So this is ethyl. What about this one? You count this one here. 1, 2, 3. This is propyl. Let's count this one again. You start counting from here. This is 1, 2, and 3. So this is a type of propyl. Like I told you, this is isopropyl. If you look at the previous page I looked at, you see that's the succeeding page rather. You see this is isopropyl that looks like this. So if you add another one here, it becomes this. So don't do that. Don't be tempted. Just count it. This is 1, 2, and 3. Now let's go to this one. This is butyl. Butyl is 1, 2, 3, 4. This is butyl. Now isobutyl is break one of these and attach it at this carbon number 2. That's what you did. So it will be 1, 2, 3, and 4. This is isobutyl. Isobutyl. And now what about this one? This is sec-butyl. Sec-butyl and tet-butyl must be written with a hyphen because sec there is a kind of suffix to them, or prefix rather. So this is 1, 2, 3, 4. You look at how this is. This looks like this one. Then you extend it a little bit again. So this is sec-butyl. You have to add this there. And then what about this? This is the Christmas light now. I told you. So this is 1, 2, 3, 4. So 1, 2, 3, 4. This one, or you can say cross, whichever you want to draw it. So this is, again, tet-butyl is a prefix. So you have to put, in their proper nomenclature, you have to put a hyphen. If you don't put this hyphen, I'm going to take away some points from you. So these are the common alkane groups. Again, metal, ethyl, propyl, isopropyl, butyl, isobutyl, sec-butyl, and tet-butyl. And now, I think we have one more thing we need to talk about before we start naming. One more thing we need to talk about before we start naming is the common non-alkane groups. The alkane groups we have to, the attachment we have to look at are not just the alkane groups. There are other common non-alkane groups we're going to see and how they are pronounced. When you see fluorine attached, it becomes fluoro. Chlorine is chloro, bromine is bromo, iodine is iodo. All these, you don't see, all these guys are the halogens group 7. These are all group 7. Group 7 or halogens. They form common attachments. So the halogens. And then these the other two, the nitro and the amino. The nitro is NO2 and then amino. Amino now is commonly found in the amines, but at times it can be suppressed when you have other functional group like the aldehyde, the ketone, the carboxylic acid. They now suppress the amine, and then you now count them as attachment. But we're going to talk about that much later. But in the examples I'm going to give you, I'm not going to bring in the amine for now. The amino, just not to confuse you. But I'm going to talk about this much later. Let us now take what are the rules for the nomenclature of alkanes. Let's now take the rules for the nomenclature of alkane proper. That's what we're going to be doing now. Number one, like I said, I've already talked about this when I talked about the IUPAC nomenclature. You identify and name the longest chain. That's the first thing. Remember, the longest chain gives the root name. It gives the root and tells you the ending. The ending will be ANE in the case of alkane family. Remember that. Now, you number the longest chain. you have to number that longest chain to give the attachment the lowest number. Remember, number the longest carbon chain to give the lowest number to any carbon to which a group or an attachment is. Then what next do? You locate and name the attached alkyl or any other group. You have to locate and name all the attachment, whether alkyl or non-alkyl groups. You have to locate them with numbers. When you have multiple branches or multiple attachments, you have to show the location number. So for multiple branches, show the location of each number, show the location of each with numbers. For multiple branches, you have to modify their name. If they are the same thing, you have to, if it is 2 methyl group, you say dimethyl. If it is 3, you can say trimethyl, 4 tetra, penta, and all the rest of them. However, you must have to separate the position numbers by comma. So the alphabet need to be separated from the numbers by comma. Then you have to list the multiple branches alphabetically. This is very important. We're going to see this. If you have like isopropyl and methyl, isopropyl is I, methyl is, so this is isopropyl, this is methyl. Isopropyl is I, methyl is M. If you have 2 of them in a branch, and after locating and giving all the numbers, you want to name them, I has to come before M first. So that is alphabetically. And again, in doing this alphabet, you cannot alphabetize all these prefixes. Di, tri, sec. You don't alphabetize them. Even tet. Tet means for tet butyl or sec. Oh, I could have written this full. Yeah. You don't alphabetize them because they are prefixes. So what you alphabetize, if I say tet butyl, you have to look at the B and not the tet. Sec butyl, you have to look at the B and not the sec. That's what it is. And then when you combine the longest chain and the branches into one name, separate the number and the letters by dash or slash. You have a nomenclature. So you have this in your note. You can always take your time to read it for more proper comprehension. But I'm going to kick it off immediately. Let's start naming. Number 1. In reflection number 1, it says, name the following alkane. Now we started off. Now I'm going to first of all try to name, label the longest chain. That's what I want to do. So if I number now, let me number. Now you can always number randomly first and take the one that is correct. So if I number from here, it's going to be 1, 2, 3, 4, 5, 6, 7. If I number from this side, it's going to be 1, 2, 3, 4, 5, 6, 7. Whichever one I number, it is heptane. That's the most important thing. Now, but what would guide my nomenclature? Where am I going to start from? Remember, you're going to number from the side that gives the number in the lowest number. Look at this. If you number from here, you have, this is, what attachment is this? This is an attachment. It gives it number 4, right? From here. And then it gives this one number 6. But when you come from here, this gets number 2 and this gets number 4. So this green nomenclature has to go. I'm not going to use it. I'm going to take it away. I'm not going to use this nomenclature. So what that simply means is that I'm going to be using the first one I did, this one. That is the proper nomenclature. So having known that the longest chain is heptane, so let me first of all write it. So this is heptane. Let me just write it here. Heptane. That's what it is. The longest chain, because this is the last root name, is heptane. Now, what do I have attached? How many attachments do I have? Let's look at them. Let me use a different color. So this is an attachment. This is an attachment in carbon number 2. This is also an attachment. So what is this? Remember, this is methyl. This is a methyl group. This is methyl. What is this? This is 1, 2, 3. So this is isopropyl. So what that means is that isopropyl is attached at carbon number 4. Methyl is attached at carbon number 2, both of them. So we have to mention the both of them. So to alphabetize, remember, isopropyl is I, methyl is M. Which one comes first? I comes first. So let's start putting everything together. So I'm going to remove this again. I already know that this is the longest chain. So let me try to move it a little bit. Remember, the longest chain, I know I already recognize that the longest chain is heptane. So that means it must end with heptane. So let me start numbering. So I comes first. So I'm going to say, despite that this is labeled in carbon number 4, it will come first. It doesn't matter because it is I comes before M. So I'm going to say 4 isopropyl. 4 isopropyl. What next? I have a methyl group in carbon number 2. So, and there are 2 of them. So I'm going to mention the 2 of them. I'm going to say 2, 2, because there are 2 of them. Because they are the same thing, what am I going to use? I'm going to use, remember, when they're the same thing, we're going to use the di, tri, and other di, tri, tetra. So there are 2 of them. So this 2 means di. So I'm going to say dimethyl. And the longest chain, like I said, is what? You don't need to put the hyphen again. It's going to be heptane. Although in some authors, I put another dash here. But in what we're using, no need to put another dash at this point. So this is 4 isopropyl, 2,2-dimethyl heptane. That is how you name this. So let's look at it again. So this is 4 isopropyl, located at carbon number 4 isopropyl, 2,2. There are two of these located in carbon number 2. That's why we say 2,2-dimethyl. The longest chain is heptane. So that is how you name this. Let's take the next one. Reflection 2 says, what is the IUPAC name for this compound? I gave you options. Let's see which one will be the correct option. Again, we have to identify the longest continuous chain. Let's see. 1, 2, 3. This can be the longest. 1, 2, 3, 4. This can be the longest. Look at this. If I say 1, 2, 3, 4, 5. This is the long chain. That's the longest chain I can identify from this. And if you count it that way, that means there's an attachment here. That means if you count 1, 2, 3, there's one attachment here. And there are 2 attachments here. So I'll likely come from here because this gives this number 2, this gives it number 3. So this will be 1, 2, 3, 4, and 5. That's my longest chain. So it's going to be a pentane. However, we know that the longest chain is pentane. That one is short banker. It's going to end with heptane. So where are the attachments? There are 2 attachments here. Methyl group is attached this, and there are 2 of them. And there's another one in 3. So what are we going to have? So there are 3 methyl groups. 3 methyl groups is going to be what? Tri. So let's put it together. So it's going to be, in carbon number 2, it's going to be 2, 2. There are 2, 2. And there's another one in 3. 3 tri methyl. Then the longest chain is pentane. So let's see where that falls. In number 2, yeah, this is it. 2, 2, 3 trimethyl pentane, and this option becomes the correct one. We go to the next one. It says, draw the condensed and expanded. Remember, we're coming back. Draw the condensed and expanded structural formula for this. 3-methyl, 2-methyl hexane. 3-ethyl, 2-methyl hexane. Now, in drawing structural formula from the name, remember, this is one of our objectives. Let me give you a secret. The first thing you need to do is to try to do what? Put the root name, hexane. We're going to try to do that. I'm going to use shortcut. Oh, it says expanded and, okay, the expanded, not the shortcut. I can put the shortcut in addition now, as in the skeletal structure. So the expanded is the long, so they said expanded, the condensed and expanded. So I'm going to do the expanded first, and then I'm going to do the condensed second. So the expanded is going to be, the longest chain is 6, so I'm going to say 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Carbon. That's what we have, hexane. And then I can label it myself. 1, 2, 3, 4, 5, 6. Now see what happens next. You see, ethyl group is attached at carbon number 3. If I come from here, 1, 2, 3, I put my ethyl groups at this point. My ethyl groups at so it's an ethyl group is C2H5. Oh no, I can use a different color. So it's gonna be C2H5. 3 ethyl. Yeah. So it's at this point. And then what else am I gonna do? Then it says, okay, let's go. It now says 2-methyl. Methyl is carbon number 2. You see, methyl is in 2, but do you know why 3-ethyl came first? Because it is E and methyl is M. So 2-ethyl. So I'm going to put it here. Oh, let me make that a little bit longer. So it's going to be CH3. So it's finished. It's a 3-ethyl, 2-methyl hexane. What do? You now complete this. Remember, this is an open structure first. So I'm going to try to put it completely. This, my numbering is too big. I don't have to make it too big. So, yeah, it's actually big. So, it's fine. I'm going to take away this one too. So, this So I'm going to renumber it again. 5 and 6. So this is how we draw this compound. And this is the expanded structural form. What about the condensed? So I'm going to do the condensed. I'm going to do the skeletal structure. What about the condensed? The condensed will be, now, remember what I told you? In the condensed, this is CH3. So I'm going to put that first. So this is going to be, so let me put that cell A. So we're going to be doing the B now. In B, I'm going to put CH3 at the end. So it's going to be CH3. And then now, all the attachment, even in condensed structural formula, must be shown. You have to show the attachment with a bond. So I'm going to say C. I have to show this bond here as CH3. You have to show the attachment even in a condensed structural formula. If not, it's going to be confusing. You have to always show the attachment. That's the best thing to do. Then, and it has a hydrogen. And then, some authors will not do that, but I advise students to do that, and that is the best way to make it so that it won't be confusing. So there's another one here too. So there's another CH that has CH2. If I put here, I'm not going to have enough space, so I'm going to position it up. It doesn't matter whether it is up or down, it's something. Okay, just know that. C2H5, ethyl group. I have this now. So I have my 1, 2. So I've done 1, 2, 3 now. So the rest, this 1, 2, 3. So I've done 1, 2, 3 at this point. This one is carbon number 2. This is carbon number 3. So I'll be doing 1, 2. So there are 2 of these. So I'm going to say bracket CH2, bracket 2. Remember when we talked about this earlier? And then I'm going to have CH3. So this is the condensed structural formula of this. So now, like I said, some authors, what they will do is to put this CH3 here as a bracket to be an attachment. That is very okay as well. But I usually tell students, I like writing it this way so that you don't have to be confused. So, okay, let's see. Some authors will put it this way, CH3, and then you put CH. On this CH, you have your CH3. That means it's an attachment at this point. And then you now have another CH. On this CH, you have C2H5. C2H5. That means this attachment is on this carbon. And after that, you now have CH2, 2, and CH3. So if you prefer to do it this way, that is also okay. And some other authors will do what even will put bracket at this point just to tell you, to show that it's an attachment. But this is another alternative way to do it. So if you now want to do the longest chain, it's going to be 1, 2, 3, 4, 5, 6. This is an attachment. This is an attachment to that carbon. So this is another alternative way. Now the last one I'm going to do it now is I'm going to show you the what? The shortcut, the skeletal structure. The skeletal structure again will be, okay, let me call that one C, just to help you, give you many perspectives to understand organic chemistry. I'm going to put the 6 carbon. So it's going to be 1, let me use my color, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is 6. Now, this is 6. 1, 2, 3, 4, 5, 6. In carbon number 2, remember this is 2. Methyl group is carbon number 2, and ethyl is this. So again, if you label this 1, 2, 3, 4, 5, 6, this is what you get. So methyl in carbon number 2, ethyl in carbon number 3. So whichever way. But when if I say draw the structural formula, you can do it this pattern. You can do it like this, or like this. But if I say skeletal structure or expanded or condensed, you have to do it like that specifically for me. All right, we now go to the next problem. So now I'm going to be a little bit fast with these ones now, just to go straight in the nomenclature without having to write the numbers and claim, because I've already spent some time trying to tell you how we go there. So now I'm going to try to name this one. If you see this, the first thing that comes to your mind, look at it. What's the nomenclature? So if a number from here now, 1, 2, 3, 4, 5, it gives this 5. If a number from here, 1, 2, 3, 4, it gives this 4, 4. And then, oh, there's an attachment that you see that. So it gives you 1, 2. I'm going to definitely 1, 2, 3, 4, 5. This gives 5. 1, 2, 3, 4. So this, the first one here is 4. And this is even 6. So I'm not even going to count from here. So it's going to be 1, 2. We're going to count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that is 10. They can. So the longest chain is 10. They can. Now let's look at the attachment. There's an attachment here, 2 and 7 and their methyl group, and there's an attachment in 5 and it's isopropyl. So I'm going to name it. So it's going to be, so isopropyl, I comes before methyl. So it's going to be 5 isopropyl. Then this is located in carbon 2 and 7, the methyl group. So it's going to be 2, 7 dimethyl. There are 2 of them. And the longest chain is what? 10. Decane. So this is how we name this structure. We go to the next one. It says, name the alkane below as well. How do we name this one as well too? Okay, again, we'll try to locate the longest. So if you come from here, 1, 2, 3, 4, 5. This is not the longest chain because this can also go. So if you come from here, 1, 2, 3, 4, 5, 6. That's a 6. Good. But where are we going to put this thing? Because if you count 1, 2, 3, 4, this gives methyl number 4 here as attachment. 1, 2, this gives it 3. So I'm counting from here. This is 1, 2, 3, 4, 5, 6. And this becomes our attachment in carbon number 3. So it's going to be what? It's going to be 3 methyl. No, there's no more attachment. So letter and letter, you don't need to separate them. It's only letter and number that you put hyphen or slash. So it's going to be hexane, the longest chain, 3 methyl hexane. All right, that is how you name this one. We go to the next one. Well, the next one now, I'm bringing in some of the foreign or the non-alkyl attachment. So this is bromine now, and it's B. Remember, it's B. Methyl is going to be, methyl will be what? M. So B is going to come before M again alphabetically. So if you number from here, 1, 2, 3. 1, 2, 3. I'm going to number from here because this is 3, but this is 2. This is closer here. So I'm going to number from here. So this is going to be 1, 2, 3, 4, 5, 6, 7. Oh, look at my counting. 7, 8, 9. That is 9, no 9. So bromine is going to come first. Bromine is located in number 3 carbon. So it's going to be 3 bromo. Then we have these 2 and 7. It's going to be 2, 7. Again, it's the same methyl group. It's going to be dimethyl. The longest chain is 9. Nonen. 9 is nonen. Remember, you need to memorize those root names. From met to dec, you need to memorize all of them. All right, so this becomes the name of this guy. We go to the next one. In our reflection number 7, what is it saying? It says, draw the structure. Oh, this one is not telling us to draw the structure again. We're coming back to this. Of 4 tet butyl, 2 nitropentane. Oh, we're coming with our nitro. So like again, I'm going to use the shortcut to draw this, the skeletal structure. The first thing you want to do is to draw your longest chain. The longest chain is heptane, 7. So I'm going to start 1, 2, 3, 4, 5, 6, 7. This is, let me count first. This is 1, 2, 3, 4, 5, 6, 7. Correct. So I have my 7. Tet butyl is located in number 4. Tet butyl, remember the Christmas tree. Tet butyl is 1, 2, 3, 4. So I'm going to put it here. So it's going to be, oh, would have given more space. So this is my Christmas tree now. This is tet butyl in the carbon number 4. And nitro is in carbon number 2. Nitro is here. Nitro is NO2. So this is how we draw the structure. Always start by drawing the longest chain. That's what I said. Always start by drawing first the longest chain. And then begin to add your attachment. So this becomes the structure of 4 tet butyl, 2 nitroheptane. Now, the last slide, the last but not the least, it says name the following alkane. Let's see. Now, okay, let's count. If I count from here, 1, 2, 3, 4, 5, 6. And this is number 2. Okay, look at this. I'm going to count this one again. If I count from here, it becomes 1, 2, 3. 1, 2. Oh, I missed it. 1, 2, 3. This is 4, 5, 6. Whichever one I count from is number 6. Now, here, my chlorine is in carbon number 2. The methyl group is in carbon number 2. That will be a confusion. Where do I now count from? What decides? Look at what decides. What decides at this point will be the alphabetical order. alphabetical order. In alphabetical order, which comes first? Chloro is C. Metal is M. So C will come first. What does that mean? I'm not going to follow the green. I'm going to follow my red counting. So I'm going to take away this. I'm going to just take away this one here. I'm going to take it away. So I'm not going to count from that one. So I'm going to count with my red. That gives this the lowest number because it comes first. So that is how you break the tie. So there's a tie in the numbering. You have to break the tie with alphabetical order. Having done that, let's now name this. So chlorine is carbon number 2. So let's name. And we know the longest chain is what? The longest chain is hexane. So what do we now do? We name it. So it's going to be chlorine in carbon number 2. So it's going to be 2-chloro. 2-chloro. This is carbon number 5. 5-methyl. 5-methyl. And then the longest chain is what? Hexane. It comes in. So this is 2-chloro. 5-methyl hexane. That is how we name this. Like again, I said, when you come to this kind of tie in the location of the number, you break the tie with alphabet. Having said that, we've come to the end of this lecture. Thank you for listening. Bye at this point.